Today we will talk about the difficulties and challenges of crosswind in landing operations. Fasten your belts because today the wind is heavy and welcome on board. Landing is undoubtedly one of the most critical phases of any flight. When the wind blows directly aligned with the runway, the task already demands attention and skill. However, when the wind blows laterally, creating the famous crosswind, the complexity increases considerably. In this situation, pilots must rely on specific techniques that balance the physics of the aircraft, precise control inputs, and sensitivity in execution. Mastering a crosswind landing is a true test of skill, where the margin for error is minimal and coordination is essential. A crosswind occurs whenever the wind component is not fully aligned with the runway. It may come from different angles, from front or behind, but it is a lateral component that creates the greatest difficulty. Pilots use information from onboard instruments, such as the wind indicator in the cockpit, and from control towers, which provide real-time data on wind direction and intensity. These data are fundamental for the captain to decide which technique to apply, since the way of executing the landing depends directly on the crosswind strength and the aircraft's characteristics. There are three main crosswind landing techniques: crab, wing low, or side slip, and the combination method. Each has advantages, limitations, and ideal situations of application. Understanding each is fundamental, not only for pilots, but also for aviation enthusiasts who want to comprehend how flight science translates into operational practice. The crab technique, named for resembling the sideways motion of a crab, is the most common in commercial aircraft. In this method, the pilot points the nose of the aircraft slightly into the wind, keeping the fuselage at an oblique angle to the runway. This compensates for the lateral drift caused by the wind, allowing the aircraft to follow the runway's center line during approach. The greatest challenge of this technique lies at touchdown. The pilot must perform a smooth adjustment, called the D-crab, straightening the nose just before the wheels touch the ground. If this transition is not well executed, it risks excessive stress on the landing gear and loss of stability. The wing low or side slip technique, on the other hand, is widely used in smaller aircraft and in pilot training. In this maneuver, the pilot keeps the aircraft aligned with the runway from the start of the approach by banking the upwind wing slightly into the wind and applying opposite rudder to counter the drift. In this way, the aircraft remains aligned to the runway axis throughout the procedure. This technique demands greater coordination, as the pilot must simultaneously control bank angle and rudder. While very effective, it can cause discomfort in larger aircraft, where excessive bank angles may compromise passenger comfort and even structural safety. The combination method is, as the name suggests, a blend of the two techniques. During approach, the pilot maintains the aircraft in crab, reducing workload and keeping the trajectory stable. Just before touchdown, he or she applies a side slip correction, straightening the aircraft in line with the runway. This is a method most commonly used in modern commercial aircraft, as it combines stability on approach with safe alignment during landing. It is important to emphasize that each aircraft has specific crosswind limits established by the manufacturer. These limits, usually expressed in knots, are strictly respected by pilots. For instance, large commercial jets may have maximum demonstrated crosswind limits between 30 and 40 knots, while smaller aircraft withstand much less. Operating beyond these limits not only compromises safety, but may also damage the landing gear or other systems. Therefore, in extreme situations, a pilot may decide to divert to another airport with better conditions. Another crucial aspect of crosswind landings is coordination with air traffic control. The tower constantly provides wind speed and direction updates, helping pilots select the best available runway. Many busy airports have multiple runways in different orientations precisely to provide alternatives when winds are unfavorable. In some cases, the pilot may even perform a go-around if the approach is not stable, demonstrating that safety always comes first. In addition to basic techniques, there are also technological aids available. Modern aircraft feature automatic flight control systems, such as Autoland, capable of highly precise landings in low visibility situations. However, when it comes to strong crosswinds, these systems have limitations and manual pilot skill becomes irreplaceable. It is at these moments that experience and training truly make a difference. Flight simulators reproduce these conditions with remarkable accuracy, enabling pilots to practice landings in varying wind strengths and directions without risk. Crosswind training is so vital that it is part of the basic pilot curriculum. In small aircraft, instructors often choose windy day for flight lessons precisely to expose students to real challenges early on. This initial learning develops reflexes and confidence that will be essential in the future, whether flying business jets or commercial airliners. From the passenger's perspective, crosswind landings may feel more dramatic. The aircraft may rock slightly, or one wheel may touch the runway before the other. This is absolutely normal and part of the technique. Many times, videos of crosswind landings go viral on the internet, showing large airliners tilted in spectacular approaches. Although they may look alarming, these procedures are carefully calculated and are part of routine aviation. In airports famous for strong winds, such as Gibraltar, Madeira, or the legendary, now closed, Kai Tak Airport in Hong Kong, crosswind landings have become symbols of pilot skill. In these locations, the combination of geography and weather imposes constant challenges, turning every landing into a demonstration of technique and confidence. In summary, crosswind landing techniques are a clear example of how aviation balances science, technology, and human skill. The crab provides stability, the wing low ensures direct alignment, and the combination method unites the best of both worlds. In all cases, the goal remains the same: maintaining the safety of the aircraft and its occupants. For the pilot, each crosswind landing is an opportunity to demonstrate preparation, emotional control, and mastery of the machine. For passengers, it is a reassurance that even in the face of nature's unpredictability, someone highly skilled is at the controls. Thus, the crosswind is no longer just an obstacle. It becomes a scenario where aviation reveals its very essence, transforming challenges into routine and risks into safe, memorable experiences.